So AI is evolving super fast, right? It feels like every time we blink, there's something new. In just the last few months, we've seen amazing models like Colors, PixArt, SD3, and now my personal favorite, Flux. Today, we'll be looking at Flux. I'll show you how to both manually and automatically prompt for it. Plus, we're going to tinker with some sample settings and figure out how to nail that perfect upscale in just one step. For this video, we'll be using ComfyUI. Now, I know that ComfyUI can seem a bit overwhelming at first glance, but trust me, it's actually pretty straightforward once you get the hang of it. It's fast, well supported, and the best part is that it's not too hard on your GPU. Let's jump in and start creating some awesome stuff with Flux. We'll keep things straightforward and easy to follow. First things first, you'll need to get ComfyUI. You can either Google ComfyUI or simply click on the link in the description below. This will take you straight to the ComfyUI GitHub page. Once you're there, scroll down until you see the installing section. You'll find a direct download link. Go ahead and click on that and the ComfyUI download will start. After it's done downloading, you'll need to extract the files. Now, a little advice, put it on a drive with a lot of space. Models tend to fill up storage pretty fast. To get everything up and running, just double-click on the Run NVIDIA GPU.bat file. Give it a few moments to install all the necessary files and repositories, and you're good to go. When ComfyUI opens for the first time, you'll see the default workflow. I'll be using the Flux low VRAM workflow in this video. You can download the workflow by clicking on the link in the description below. Along with the workflow, you'll need the Flux Dev or Schnell model. Just make sure you download the 4 quantized version. Navigate to the models directory and place it in the UNet folder. The Q4 model is perfect for systems with around 6 to 8 gigabytes of VRAM. You'll also need to grab a couple of clip models, one from OpenAI and the other being the T5 FB8 model. You can also download the quantized T5Q4 model if your system is really struggling to cope. And if you're aiming for a touch of realism, download the realism lora available on Civet AI, link also in the description below. Lastly, you'll need to download at least one large language model. For this video, I'm using the Mistral V3 quantized model, which has been working great for me. Before I forget, place both clip models in the models clip directory, the lora in the models lora directory, and the large language model in the models lava checkpoints folder. Now there's one more step before we can start, and that's installing the ComfyUI-Manager. This tool makes it super easy to install any missing nodes for the workflow you just downloaded. Head back to where you downloaded ComfyUI and find the folder with the Run NVIDIA GPU.bat file. Navigate to the custom nodes directory inside the ComfyUI folder. Then type CMD in the navigation bar and press enter. Click on the link in the description below to go to the ComfyUI-Manager GitHub page. Copy the URL, then go back to your command prompt and type git clone followed by the URL you copied. This will clone the manager into the custom nodes directory. Next, navigate back to the folder with the Run NVIDIA GPU.bat file. Enter CMD in the navigation bar and add the command listed in the description below to install all the requirements for the ComfyUI-Manager. Once that's done, close any open command prompt windows and double-click on Run NVIDIA GPU.bat again. Wait for it to finish. ComfyUI will auto-open on your default browser. Drag and drop the Flux low VRAM workflow into the workspace. You'll notice some red nodes. These are the ones missing from your installation. Click on the Manager button to open it. Select Install Missing Nodes. Select the notes and then uninstall. The manager will prompt you to restart. Click to restart and close the manager. That wasn't so hard, I think. Anyways, once this is all done, you're all set. Quick note before we dive in. Flux is pretty demanding. I mean, both VRAM and RAM screams in pain with the slightest load. Even the smallest quantized versions can be heavy on your PC. My advice? Close everything else, keep only one tab open. This allowed me to get 10-minute generations with just 8 GB of VRAM on a 1070 and 12 gigs of RAM. And to think I used to wait for 30 minutes to an hour each time I changed a prompt. Now with all that setup out of the way, let's get started with the fun part, prompting for Flux. Honestly, this might be the easiest model to prompt for thanks to the T5 clip model. Unlike other models where you might need to overflow your prompt with tags, Flux lets you use natural language, which is a breath of fresh air. But there's still a bit of a formula to get the best results. First off, be descriptive. Seriously, no more throwing in random words or vague phrases and hoping for the best. Flux thrives on details, so give it specific information about your subject and scene. For example, instead of saying a portrait of a woman, which could still give you a nice image, you could say a close-up portrait of a 20-year-old 90s British woman with golden silky hair, green eyes, and freckles, wearing a top with the letters rock and roll on it. The second prompt is detailed and tells Flux exactly what you're looking for. Next, Flux is amazing at rendering text, which opens up a ton of creative possibilities for your prompts. You could prompt for something like, create a magazine cover design with the word Flux Dev written in bold white letters at the top of the cover. The word prompt is written in a smaller white font below it. There is a face on the cover that is made up of different colors. The face has a large smile on its face and is surrounded by multicolored circles. The circles are different shades of pink, purple, green, yellow, and blue. There are smaller circles of blue and green scattered around the face. The background is a dark shade of black. To the right of the face is a text that says Advanced AI Study in white letters. Underneath the text is a list of words that say Power of Flux, Color Create, Inspire, Run Flux on a Potato, and Photorealistic Evolution. Just imagine how easy prototyping just got. I mean, look at this image. I wouldn't be able to come up with something like this if you gave me a brain transplant. Another great tip is to use contrast and juxtaposition in your prompts. This means placing two elements that don't usually go together to create a striking effect. For instance, you could prompt something like, create a realistic image of an astronaut in a lush, dense jungle. The astronaut should be standing on a mossy rock in the foreground, with the jungle stretching out behind him. His helmet should reflect the vibrant greens and sunlight, creating a stark contrast between the high-tech suit and the natural environment. The jungle should be alive with various plants, animals, and insects, with bright, warm lighting filtering through the canopy. This kind of contrast really makes your images pop. Another cool thing about Flux is how well it handles unusual perspectives. You can spice up your images with angles like Dutch angles, fisheye lenses, or macro perspectives. For example, you could prompt, create a macro perspective view of a dew-covered spider web in the early morning. The web dominates the foreground, each thread sparkling with dew droplets, reflecting the soft golden light of the rising sun. The blurred background reveals a lush garden bathed in soft light, with hints of colorful flowers and leaves. A small spider, intricately detailed, is positioned at the center of the web. The overall mood is serene and detailed, capturing the intricate beauty of nature up close. The prompt adherence is amazing. Using these perspectives adds a whole new layer of creativity to your prompts. Another thing, don't forget to describe the mood and atmosphere in your prompts. Let's say you want a misty twilight forest in autumn, just after a light rain. The ground is covered in vibrant red, orange, and yellow leaves. A narrow, winding path, slightly obscured by the mist, leads deeper into the forest. Ancient, towering trees with twisted branches form a natural canopy, their bark glistening with moisture. The atmosphere is serene yet mysterious, with a faint golden light filtering through the mist from an unseen source, adding a magical glow to the scene. In the distance, a small rustic wooden cabin with smoke gently rising from its chimney offers warmth and refuge. Even though the prompt is long, it ensures that the image includes every detail you envisioned. The forest in autumn, the ground is covered in vibrant red, orange, and yellow leaves and ancient towering trees. The bottom line is simple. Tell Flux exactly what you want, and don't be vague. If you incorporate these elements into your prompts, you'll be consistently creating amazing amazing images every time. Now that we've got a handle on prompting Flux, let's take a closer look at the workflow we'll be using today. It's a pretty straightforward setup, but super effective. The workflow is divided into 4 main parts. Auto prompt generator. This is where it all starts. The prompt generator creates prompts based on what you want, your subject, the type of prompt, and the style you're going for. It's a handy tool that gives you a solid starting point without having to manually type out everything from scratch. The next part is the image to prompt. It uses Florence 2 to automatically caption the image. Then it feeds that prompt into the Flux text to image section. The third is the low VRAM text to image section, and the last section is the upscale section with a low VRAM solution. The workflow is all about efficiency. It's designed for systems with lower VRAM, so if you're working with limited resources, this is how you'll get the most out of Flux. It still delivers high-quality images, but it's optimized to not overwhelm your system. Alright, so before we dive into the full workflow, let's first focus on the large language model section. I've included a prompt creator in the workflow to help you craft those perfect Flux prompts. The model I'm using for this is the Mistral 7B V3 model. Now, there are a few settings you'll need to tweak to get the best results. Here's what I found works well. Temperature. Lower temperatures tend to produce more cohesive and logical responses. I usually set it to 0.4. Anything higher, and the model can start to generate less focused output, almost like it's talking to itself. Top P and top K. These control the randomness of the output. I lowered the top P to 0.4 and set the top K to 10. This fine-tuning helps in generating more relevant and focused prompts. Repeat penalty. This is crucial for avoiding repetitive text. I found that setting this to 1 gives better results, preventing the model from getting stuck on certain phrases. I also increased the context length to 4032, which allows the model to handle a longer system prompt. But be cautious, because if you set this value higher than what the model can handle, it might not work properly. As for GPU settings, keep the GPU layers high if you're working with low VRAM, and reduce the number of threads to either 5 or 2. This helps manage the load on systems with limited resources. With those settings in place, let's talk about the system message. This is essentially the set of instructions you give the large language model on how to interact with you. In my setup, I've added a prompt guide from giz.ai along with some custom instructions to guide the model's output. Now, let's break down the options in the request box, where you'll craft your prompt. First is subject. This is where you define the main subject of your image. For example, let's go with a beautiful elf woman in a fantastical world. For the type of prompt, choose between different types like normal prompt, layered prompt, temporal narrative prompt, style fusion, or juxtaposition. For this example, let's stick with a normal prompt. As for style, you've got 2 options here, realistic or artistic. I'm going with realistic, but you can experiment with specific art styles if you're feeling creative. Next up is the string function, which holds the final prompt. Above it, there's the string variable, where you can add extra tags you want at the beginning of the prompt. I added photo, realistic, hyper-realistic, ultra-realistic, best quality to make sure the image hits those high-quality marks. There's also another string variable below for tags you want at the end of the prompt. I added cinematic here to give it a polished, movie-like finish. Once you've set all that up, go ahead and cue the prompt. You'll see the tags injected at the beginning and the end of the prompt, ensuring everything is tailored to your vision, and that's it. With these settings, you're set to create some amazing detailed prompts with ease. Let's move on to see how it all comes together in the workflow. Next, let's look at the Flux text to image section of our workflow. This part is where the magic really happens, and it's divided into 2 main sections. The first section consists of the loaders. Here we've got a few key components: the UNet loader, dual clip loader, VAE loader, and lora loader. For the UNet loader, I'm using the FluxDev Q4 model. I found that it runs smoother on my system compared to the Schnell Q4 model, which in many ways is strange. It's supposed to be the other way around, but Schnell kept giving me longer generation times. In the dual clip loader, we load 2 models, the OpenAI clip model and the T5 FP8 model. I tried using the T5 quantized, but it slowed down my generation times, even though it was easier on my GPU. The second section is made out of styling and switches. This is where things get a bit more customizable. First, we have the SD Prompt Styler and Perfection Styler. These are crucial for adding built-in styles and technical details to your prompts. The Perfection Styler, in particular, really helps refine the prompt for those high-quality outputs. We've got a switch here to toggle between different inputs, whether it's text to image, image to prompt, or the large language model to prompt that we set up earlier. Next, we have a show text node to display the final prompt, followed by the clip text encode and a custom sample node. The custom sample node is basically a bunch of nodes that have been bundled together into one for simplicity. There's also a latent input switch to toggle between text to image and image to prompt. That's if you want to use the image as a latent. And finally, the empty latent VAE decode and image preview nodes to wrap things up. Let's go back to the custom sampler for a moment. When it comes to the sampler settings, I usually go with Euler for the sampler and simple or beta for the scheduler. I use a guidance scale of 2 with a max shift of 0.7 and a base shift of 0.2 for my everyday workflow. This setup works well for most images and gives me consistent results. For cinematic images, use DPM2 and colors with a guidance scale of 0, a max shift of 0.2 and a base shift of 0.2. This settings gives a more rugged film-like quality to the images. Now, you might be wondering why I use different settings. Let's break it down with an example. We'll use the following prompt: capture a hyper-realistic full-body shot of a woman with a cyborg physique, clad in a white and silver metallic exoskeleton, but looks both futuristic and battle-worn. The silver metal angel wings on her back are folded slightly, with each feather engineered with intricate details, blending smoothly with the mechanical components. The lighting is dramatic, with a cool blue tinted light source highlighting the metallic sheen of her body, while softer, ambient light adds depth to the shadows. The scene is set against a backdrop of a ruined cityscape, with debris and twisted metal structures barely visible in the distance, creating an atmosphere of post-apocalyptic tension. The image is captured with a wide-angle lens, 24mm at f4, enhancing the scale of the wings and the environment around her. For the first image, I am using Euler for the sampler and simple for the scheduler with a guidance scale of 2, max shift of 0.7 and base shift of 0.2. No lora involved here. The result is a smooth, detailed image, especially the wings. They look fantastic. For the second image, I am using DPM2 and Karaz with a guidance scale of 0, max shift of 0.2 and base shift of 0.2. This gives the image a gritty, rugged look, almost like a scene from a sci-fi film. Third image, I cranked up the guidance scale to 5 with a max shift of 0.7 and base shift of 0.2. The result? A shiny, polished look, yet still with that great detail. As you can see, tweaking these settings can give you vastly different results, even with the same prompt. The first image has that smooth, clean look, while the second is rougher and more cinematic. The last one, with the higher guidance scale, adds a shiny, almost ethereal quality to the image. So, the takeaway here is play around with these settings to find what works best for you and the kind of images you want to create. The choice is yours. Next, let's look at the image to prompt group. This group is made up of the load image node that ports into the Florence node. This generates a prompt from the image using the Florence 2SD3 caption model, which is then sent to the switch. This model is fantastic for creating detailed and accurate descriptions from images. It's a computer vision model developed by Microsoft, specifically designed to extract rich insights from images and videos. Here's how you use it. First, upload the image you want to turn into a prompt. Select the more detailed caption option to get a richer, more descriptive prompt. Choose the model you want to use. In my case, it's the SD3 Captioner. Once you've got everything set, press Q and let it run. The model will download automatically the first time you're using this group. Don't worry if it takes a minute. The prompts that come out of this process are always a pleasant surprise, often capturing details you might not have noticed yourself. There's so much you can do with Florence, and I plan to dive deeper into its capabilities in a future video. For now, this should give you a good starting point for generating prompts from your images. We've reached the final part of our workflow, the the upscale group. This section is where we take our images and really bring out the details, making them pop. We'll start the upscale group with the load image node. This is where you load the image you want to upscale. Next to this is the positive and negative text encoders and the load upscale model node. Here, we're using the 4x ultra sharp model, which does a fantastic job at enhancing the image quality. The image save plus the image compare lets you compare the original and upscaled images side by side. I've included a custom Flux upscale factor selector. This is a handy tool that automatically calculates the final tile width and height based on the upscale factor you choose. One of the cool things about this setup is that if you decide to upscale by, say, 2x, then the tile width and height automatically adjust to maintain a seamless, high-quality image. It's all handled in the background, so you don't have to worry about it. These are a bunch of nodes grouped together. You can ungroup them if you like. Now, if you take a look at the steps involved, you'll notice that I only use one step. That's really all you need. I keep the CFG at 2 and the denoise level at 0.2, which strikes a good balance between detail and smoothness. Just to give you some context, I'm running this on an older GTX 1070 with 8 GB of VRAM and about 12 GB of RAM, and it works perfectly fine. So even if you're on a lower end setup, you should be able to follow along without any issues. I've also included a switch between the text to image group and the upscale group. This allows you to choose whether you want to use the image generated from the text to image process or load a separate image for upscaling. For this demo, let's use the image we created earlier. Let's cue prompt and wait. This might take a while, but is totally worth it. The upscale process enhances the image beautifully, even capturing those intricate details, all with just one step. So, as I mentioned earlier, this workflow is perfect if you're running ComfyUI on a low-spec system. The large language model to prompt, image to prompt, text to image, and upscale sections all work smoothly, as long as you close everything else and only keep ComfyUI open in your browser. That's it for this video. You'll find all the links to everything we used in the description below. This is my first official video. Subscribe or like if you can, so I can give you more videos like this. Thanks for watching, and I'll see you next time.